Hello everyone, this is Reza and welcome to another video of FX series in Maya. In this video, I will show you how to create a smoke effect using Bifrost Aero solver. Now, Aero solver and Bifrost Graph are new additions to Maya and they're absolutely amazing if you would like to create combustion, if you would like to create any type of simulation including cloth, smoke, fire and even snow. Now, to use Bifrost Aero and Bifrost Graph, you need to make sure that your Bifrost plugin is loaded into the interface. Also, you need to make sure that in Time Slider, your playback speed is set to play every frame. If that's the case, you're good to go. Now I have a very simple scene. I have a fireplace here with a chimney, and this is a perfect excuse for me to create smoke. Now, if I render this scene really quickly, you can already see that I have gone ahead and textured the scene and add some lights into the scene. So lights are mainly just one simple sky dome and a directional light. And the good thing about Bifrost Aero is you can go ahead and light your scene beforehand, and you don't need to worry about self-lighting or adding ambient after the fact like the legacy fluid container. All right, I'm going to close this window. And the way we start with the new Bifrost system is through Bifrost Workspace. You can either go to Windows and go to Bifrost Graph Editor, or you can enable the tab via the plugin and go ahead and just click on Bifrost Graph button here. And that brings you this Bifrost node, a graph editor that is actually, you do everything from start to finish in here. So let's go ahead and have a look at this interface first. Now, if you already have a Bifrost node in the scene, you can go ahead and click on this plus sign and load it here. Well, my scene is empty. I have no existing Bifrost node, so I can either click on new graph or go ahead and create graph from here. Now, as soon as you create your very first node tree, you always get two nodes. Now, just like Maya, you can middle click and drag, and you can alt right click and drag to left and right to zoom in or out. You can also use your mouse wheel, and you can press F to frame on a specific node, or you can press A to frame all. Now, every time you select a node, you can see the parameter editor and info tab on the right hand side, and that changes based on the selected node. You also have info panel to gives you extra information about keywords of that selected node. So it's very useful, and I encourage all of you to take a peek at that when we add main simulation nodes to the graph editor. Now, first things first, I need an emission for this chimney. I can actually go ahead and select a polymodeling and a sphere and add this as emission. And the way you do that, you go and create a sphere, and you just middle mouse and drag to create your node. Or you can actually make your model here by pressing tab, go to modeling, primitive, and create mesh sphere. It pretty much does the same thing, and you can just tweak dimension, you can transform it in space, and you can play around with its axis and height segment. Now I'm going to spend a little bit more time on this node. You can see in here we have the name of the node, and the default name is based on the node's type, but you can double click on it and change it if you want. Also, you noticed a diamond shape in here, and it just indicates that you brought this node from its library. So Bifrost calls it a referenced compound. So if you bring a node from a reference compound, you get that diamond look. Whereas if I bring this sphere in here, you can see there is no diamond in here. I select it and press delete. Also, as you have noticed, I clicked on the plus sign, and I can press on the minus sign to expand and collapse my port groups to see what's underneath each attributes. In addition to that, some nodes have input or output ports, which is very handy. And of course, last but not least is the icon. So that node icon is actually very useful, and it's usually related to its function. All right, let's go ahead and create our smoke. I'm going to reorganize the graph. At any point of time, if your graph is messy, you can just press L and it lists it for you. I'm just going to go and create the output, and I don't need input anymore. I already have my emitter as input. I can actually go ahead and call this sphere underscore emitter, since this sphere is going to be our emitter. Now, in order to see this emitter, I can just go ahead and connect it to my output. That's the simplest form of a Bifrost graph node. Now, all of a sudden, in parameters, I have a few attributes to work with, not mention that in my outliner, now I have BIF number 1. And that shows that the very first Bifrost graph has been created. Now, if I minimize my Bifrost graph editor and have a look here, you can see that my emitter is now visible. And my Bifrost graph node is also added to my outliner. Fantastic. But of course, we've got a long way to go, and we need to add way more nodes to create that smoke. So let's go ahead and do it. Now, the first thing that you need when you create a smoke is a source node. If I press tab and just type in source, there's a node called source air. And that turns my emitter into a source of air. And it's as easy as out purple into in geometry purple, and done. If I look at its attribute, you can just single click on it and look at its attribute. You can enable or disable the air source. So basically you can just turn off its evaluation if you want to. You can set the resolution mode to relative, so when you change the scene scale, it's still going to adapt itself to its scale. Geodetail size and fluid detail size is very much similar to base resolution, but when you bring down this value, you're actually increasing the quality. So what I can do, I can just increase its quality to 0.025 and do the same thing with the geometry. Also, for the air property itself, you can just specify how thick the fog you want to be. And in here, about density, we actually call the density a fog value, fog density value, and that indicates the density value. So every time I say fog density, I just mean density value. And if you don't know what density is, I highly encourage you to have a look at my smoke trail using 3D fluid container video, because I go and talk about that in depth in that video. Now I go fog density, and I'm just going to increase this to a number of 5. And then I want my fog density to be set, and the temperature that fog density uses is also very important. It's not going to change the color of my density because there is no fuel, but still very important on how the density behaves. And I want that to be at max. We do need initial speed, but since it's a chimney smoke, I'm not going to go too crazy with that initial speed. I'm just going to set this to 1. And of course, I want this to rise. So I'm going to X, Y, Z, set 1 to Y-axis. Again, I want speed mode to be set to max. And I do want to have inherent velocity to have that initial push. So inherent velocity of 1 usually does the trick. And that's it. Let's go ahead and create another node. Now the next one that is actually very essential in order to create that smoke simulation is, if I press tab, it's actually a simulate node. Once you type in simulate, you get different types of simulations. One is for particle, one is for aero. So I'm just going to click that, bring it in here. Again, air source goes to source, air source goes to source. And you may have noticed immediately that I have other outputs as well. One is collider. You can bring a collider object using collider, and you can have a geometry attached to that collider, and that collider goes in here. Simple as that. I do not have any collider, so I'm not going to do that for this project, but just so you know, it is really easy to bring a middle mouse and drag your collider into the scene and plug it to the collider node. Now let's have a look at this simulate aero and see what we have. Well, not much. Simply because this just does this simulation, but all the attributes are actually coming from source air. So this becomes extremely important to what type of smoke are we feeding to the simulation engine. It's like a machine that just simulates the data coming from source air, and again we can just output it out and see the result. Now before I connect my simulation to Aero, there's something else that I need to add which is as important, and that is this setting right here. You can see if I click on that simulate aero setting, there's actually not much setting going on here, and it's empty because settings itself is a node. So I'm just going to tap and go settings, and you can see we have aero solver settings. Now this menu is one of the main components. So these 3 nodes are essential for our solver to produce smoke. Now how to plug it again is very easy. Solver settings goes to settings. Now this aero solver creates some global attributes, and it will overwrite what you may specify to the other nodes. For example, we have aero solver globals, where you specify your temperature and style of your smoke. You may want to have a fluffy smoke, busy smoke, or wispy smoke. Now, just so you know, usually if you're looking for a puffy smoke, smooth is not a good option. I usually set it to either fluffy or busy, which is actually quite dense and takes a while to render. And wispy kind of falls in between these two. So for now, I'm just going to go and pick fluffy. And simulation speed of 1, it's actually the speed rate that we used to have in fluid containers. It is not too bad, but with chimney and wood smoke, we are dealing with a much slower rate, so 0.75 should be okay. We do want to have a buoyancy, and it's negating the movement, simulating gravity, so it's actually helping the fluid to rise. That's good. We would like to kill any voxel with the value of 0.01, which is practically invisible. So rather than calculating this, Maya's gonna just go ahead and kill it. You can actually increase that to improve on the previewing and play blasting, but you got to be very careful, otherwise you might see some really odd artifacts on your fluid. Now, scene scale in meters set to 1, and that is very important. So I'm going to leave my scene scale meter at 1. Accuracy and diffusion handling, we don't need to worry about them because this is for fast moving objects, and this is for blurring the simulation, and it kind of defeats the purpose. We'll kill all the details that we may have. So let's go ahead and plug the Aero volume to sphere mesh and do a quick play blast. I'm just going to go play blast, and let's do a quick play blast, and we come back. So, well, while I really like the speed, there are a few problems in here. Well, one problem is the emitter sim's a bit dark, and I think I need to tweak the density and temperature a little bit. And all in all, while as a first pass it looks good, we still need to make quite a number of adjustments. So let's go through that and do a second pass of tweaks on the work. So I'm just going to bring back my node, and if you have noticed, there are two things that we can do. One is to add randomization to temperature and to my density. In a normal Maya node, you can shift right click or control right click and add expression. In here, we have a node for it, and that node is called vary source. So if I just type in vary source property, I can have one vary source for density, and I can have another vary source for temperature. Now let's bring them in. So it actually falls between your source and your emitter. So from the emitter to the geometry, and I don't need that anymore. Then, since I have the secondary vary source, I can go just out geometry to the other geometry, and from out geometry to in source geometry. It's very, very intuitive and straightforward. And it's really enjoyable that there is not much learning curve. Everything just works. So as the name suggests, it varies or randomizes the attribute that we have. It can be size, it can be value, it can be a specific property or multiplier. The only thing about vary source is it asks for a property. It doesn't work without that property. Now, we already mentioned that the property we're aiming for smoke is pretty much density, and the way that Bifrost understands it is by fog density. That's the label that Bifrost has assigned to the density value. So let's see what we can do to randomize it. I do want to randomize the variation. So min can stay at 0, I can just set 3, maximize it. And for bias, I can set it to -0.5. Now, bias works really interestingly. If you set it to 1, it actually looks at just max. If you set it to 0, it looks at min value. And if you have 0.5 or -0.5, it kind of shuffles in between, and with the animated attribute ticked, it creates really, really awesome effects. Now let's go ahead and do the same thing for vary source temperature. I'm just going to select that, go to its property, and we add temperature. Now for temperature, we do use high values. So minimum to 20 and maximum, let's say, go something crazy like 1000. Again, we want animated attribute to be ticked off, and that's something that we need. Also, another thing that I think it's missing is force fields. Now, force fields in Bifrost Graph Editor is called influences. If I just type in influence, you can see I have a dissipation, drag, gravity, influence. I can also go to simulation and go to influences, and in here you have access to even more influences. Now, what I really like, and I think it's absolutely essential to have, is dissipation influence. So I'm just going to move the error solver and create dissipation out to influence, and immediately we can see that the property it recognizes is voxel fog density. So it's actually targeting our density, which is great. It's very similar to dynamic relationship editor in Maya. Now, about this node, it's very straightforward. The higher the rate, the sooner it dissipates. Value of 1 works for me. I'm just going to increase it to something like 1.5, and that's it. Let's go ahead and add another influence. So this time I'm going to go to simulate, influence, and I may actually pick vorticity. And vorticity is very similar to turbulence influence. So if I go to simulate and influence, we have turbulence influence, which is great. We also have vorticity influence. It's a very simplified version of turbulence, but it doesn't have a frequency like turbulence influence, but very, very simple and easy to use. So I'm just going to enable that, put 1.5 to vorticity. We don't need to change the scale. We just go from out into influence. Now, every time I add vorticity, I would like to randomize it as well. Just like these guys where we have vary source, we have a way of randomizing the force field and our influence nodes in Bifrost Graph Editor. And that's called modulate influence. So if I type in, go to simulation, and if I go to influence, we can see we have modulate influence. And the name suggests its functionality. It modulates the influence. It gives it a min and max. So I'm going to set min to 0.25 maybe, and I'll leave the max as is. That works just fine. Again, be careful, make sure it targets the right attribute, not temperature, but density. While I have this one here, let's go ahead and add wind as well. So I'm going to go to simulation, influence, and this time I'm just going to add from influence, I'm just going to add wind. I'm going to bring it here. I may need to go full screen to have access to all of these guys. Again, that goes to influence. And just like what I did vorticity, I need to add modulate influence. Control D doesn't work. So I'm going to go to tab, simulation, influence, and modulate influence, just to add a little bit of randomness. Again, I honestly think that default 0 to 1 works for me, just for us to have a little bit of randomness in here. For wind itself, the strength of 5 in x-axis probably works. Just want to keep it relatively straight. So drag 0.2 is fine. All right, that should work for now. Just so you know, you can always right click inside Bifrost Graph node and create a backdrop. So I can actually go ahead and have that backdrop and include these nodes into my backdrop. So every time I actually move the backdrop, it moves all the nodes inside it. It's just a much cleaner way of working. You can actually click on that backdrop and you can just call this influence. All right, with that done, let's go ahead and have another play blast and see what we're getting this time around. Okay, play blast is done. Let's have a look. I think I went overboard with dissipation. I really like the vorticity and the turbulence. So that part of it is good, but it dissipates way too quickly. I think it's because of that value of 1.5 that I gave to dissipation value. So if I go and click on dissipation, rate of 1.5 turned out to be not ideal. So I'm just going to probably reduce it down to 1.1. And that should really help the situation. I'm very happy with vorticity and the way that wind works, but again, I'm not too keen about that black puff that I'm getting. So let's go and tweak the material using Hypershade in Maya. So I'm going to minimize my graph, and I noticed that I'm getting a little bit of artifact with my ambient occlusion and with my lights on, so I just turned them off. I'm gonna just go and open my Hypershade. Now the material I would like to give to the smoke is under Arnold, Shader, and AI Standard Volume. I kind of like this material. It works really well with what I have, and it's got all the right attributes. I just need to make sure that I'm giving its channel all the right keywords. So with that in mind, I'm just going to say I would like to give my material density of 1, but not just to density channel, but rather voxel fog density channel. Now, I would like to give it a white color. So put the scatter to white, and transparency, it's really up to you. You can kind of reduce the transparency and get a much thicker result. And you can just increase the transparency and get a very opaque result. It's up to you. For now, I'm just going to just give this 0.5. I think the default value is way too thick or opaque. Just on that note, you just need to be mindful of the fact that we are not going to give transparency any specific channel, because just like scatter, transparency also is going to affect both density and temperature. For emission, I want to give it a channel, and I'm just going to give it a really thick blue color. And again, for emission, I really would like this to affect my density, not temperature. And that's important. In your temperature value, you're not going to just use temperature. We are going to kind of label it correctly. So it's going to be voxel temperature. Black body Kelvin is way too high. And with that, we might get a look of a fire. I just want to tone it down quite a fair bit. Same with the intensity, a very, very low value, something like 0.002. That might even be too high. We'll see how we go. All right, it's almost there, but we haven't assigned it. It's not like we got to drag and drop it. That's not how it works. So let's see how we can assign that. First things first, let's actually bring it over. I am going to bring this guy. Just going to put these windows side to side. And it's just as simple as middle mouse, drag and drop. And you have your material. How to assign the material? Well, through the assign material node. It's very straightforward. So volume goes to volume. Aero volume goes to geometry. And out to sphere mesh. Simple as that. Now we have the material assigned, and let's just zoom in a little and see what we're getting. If I just play, the first few frames kind of indicate what type of material I'm looking at. So right off the bat, what I'm noticing is that's not good. If I go to transparency, I can see that all I'm getting is mainly the emission. So the good thing about, and I intentionally did that so I can show you, the good thing about this type of workflow is you can actually go back and change this on the fly right now, which is really cool. I can go increase my density to something like 3 or 2, and you can just go ahead and fine tune the look of your work. I may switch back to black background because I really want to see how things are looking. I may actually increase my light to something like 0.3. See if that makes any... Yep, that does make a difference, which is good. Now let's go ahead and play blast that and see how it looks. And then we come back and tweak this further if need be. All right. Alright guys, here's the result. I've play blasted the whole thing. Let's go and render it through the proper render camera, and we're gonna have a look at the end result rendered obviously and see how it's looking. Alright, I've gone ahead and rendered 150 frames using All-Node Renderer, and here's the result. I hope you enjoyed this tutorial. Thank you very much for tuning in, and see you in the next video.